everyone! Welcome back to my channel. So for this day, we will be learning about set operations and Venn diagram. By the way, I am Miss Anaflor ACCabalda. But before we start, let us first have our objectives. And these are, first, define a universal set. Next, define a Venn diagram. Third would be use Venn diagram to show relationship among sets. Fourth would be define set operations. And the last one would be solve some problems using Venn diagram. So what are we waiting for? Come on, join me in learning set operations and Venn diagram. What is a Venn diagram? It is a general set that contains all elements under discussion. It is usually represented by a rectangle. As you can see in the drawing, the shaded part or the blue part is what you call as the universal set. Next, let us discuss the Venn diagram. A Venn diagram is an illustration of relationships between and among sets or groups of objects that share something in common. As you can see in the drawing, you have four Venn diagrams showing the intersection of the different social networking groups. It was created by John Venn during the 19th century. Okay, let us have some examples. Based on the drawing, what are the elements of the universal set? So, the elements of the universal set would be the square, the triangle, M, 5, and the dollar sign. Let us have the elements of A. So it's obvious in the drawing that that would be the square and the rectangle. And what would be the set of elements in U that are not in A? So it would be the dollar sign, M, and 5. Okay, are you still with me? Okay, let us have some information or more information about the Venn diagram. We have disjoint sets. Those are sets that have nothing in common. So, based on the drawing, they are separate from each other. We also have proper subsets. All elements of set A are elements of set B. So that would be the illustration found on the right side of the PowerPoint. Next, we also have equal sets. If A equals B, then A is a proper subset of B and B is a proper subset of A. And we also have sets with some common elements. So for this set, they have an overlapping part. So as you can see in the diagram, the shaded part in the middle is what you call as the common element of set A and set B. Okay, let us have some examples. Determine the elements of the universal set. So of course, if we will say universal set, it pertains to all elements in the rectangle. So that would be A, B, C, D, E, and F. Next, what are the elements of B? So that would be D and E. How about the set of elements in A but not in B? So that would be A, B, and C. Okay? So let us proceed to the next important information. And that would be set operations. What are these? When two or more sets combine together to form one set under the given conditions, then operations on sets are carried out. So we have 5 basic set operations. And these are union, intersection, complement, difference, and Cartesian product of sets. I will be discussing to you the different definitions of these set operations with examples. Union of sets. The union of sets A and B, written as A union B, is a set of elements that are members of set A or set B or both sets. So we have the notation and we have the drawing. So meaning all the elements of A and B. That would be the union of the two. For example, we have letter A. Set 1 contains numbers 7, 8, 9, 10, 11, and set 2 contains 6, 8, 10, and 12. What would be the union of the two sets? So meaning, it would be from 6 to 12. How about letter B? You have 1, 3, 5, 7, and 9, union of 2, 4, 6, and 8. So that would be from 1 to 9, all the elements of the given set. How about 1, 3, 5, 7, and 9, union of the null set? Since a null set has no element, so the union of the two would be 1, 3, 5, 7, and 9 only. Gets? Okay, let us proceed. Let us have the intersection of sets. When you say intersection, that means there is a common element between set A and set B. Okay. So, in the drawing, it is found in the middle part, or the part that has overlapped, because they are overlapping with each other. Then that overlapped circle would be the intersection of the two sets. For example, what would be the intersection of 7, 8, 9, 10, 11, and 6, 8, 10, and 12? So that would be the common of the two given sets would be 8 and 10. How about letter B? Common of 1, 3, 5, 7, 9, and 2, 4, 6, 8. As you can see, both sets have nothing in common. So the answer would be null set. Next, 1, 3, 5, 7, 9, and the null set. So there is nothing common in the two given sets, so the answer is still a null set. The complement of a set. What is a complement of a set? The complement of set A, symbolized by A prime or A with a bar on top, is the set of all elements in the universal set that are not in A. So based on the drawing, it is the yellow shaded part, so that would be the complement of set A. For example, given the universal set contains the elements 1 through 9, and A contains 1, 3, 4, and 7. Find the complement of A. So, it's very simple. All you have to do is to find those numbers that are not in A. So, that would be 2, 5, 6, 8, and 9. Found outside set A. Next, set difference. Set difference means that the difference of set B from set A, denoted by A minus B, is the set of all elements of set A that are not in set B. So, it simply means that all you have to do is to see all the elements that are in set A alone. Okay? So, in the drawing, the shaded part contains all the elements that are purely for set A. For example, if A contains elements A, B, C, D, and E, and B contains elements A, E, F, and G, find A minus B and B minus A. So meaning, A minus B would be all elements in A that are not in B. So the answer would be B, C, and D. For B minus A, all elements of B that are not in A. As you can see, those elements are F and G alone. As you can see, A minus B and B minus A there are instances that the set difference will not be equal with each other. And this is one proof of that. Last set operation would be Cartesian product of sets. The Cartesian product A and B, A times B between two sets A and B, is the set of all possible ordered pairs with first element from A and second element from B. So with the diagram, it illustrates that all you have to do is to multiply the elements of A and the elements of B, and when you write the two answers, you have to separate them with a comma, since that would be the x coordinate and the y coordinate. Okay, let us have some example. If A equals 1 and 2 and B has elements A and B and C has elements 5 and 6, what would be the Cartesian product of A, B, and C? So as you can see, first step is to multiply A and B. So that would be 1A, 1B, 2A, and 2B. Next, the answer for the product of A and B will be multiplied to the elements of set C. And that would be 1A times 5 would be 1A5, 1A6. Next, 1B5, 1B6. Next, 2A5, 2A6. Next, 2B5 and 2B6. The elements that I have mentioned are the answer to the Cartesian product of set A, set B, and set C. Okay? Now, let us perform some set operations. You have the given universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. A has 1, 3, 7, and 9, and B has 3, 7, 8, and 10. What would be A union B, and what would be its complement? First step would be to find the elements of A union B, and that would be 1, 3, 7, 8, 9, and 10. So all the elements of A and B. However, the question states that what would be its complement? So meaning those numbers that are not found on our first answer. And that would be 2, 4, 5, and 6. No? You have to base your answer, or you have refer your answer to the given universal set as well. Next, what would be A complement intersection B complement? So first step, you have to find A complement, and that would be those elements that are not in A. So you have 2, 4, 5, 6, 8, and 10. And B complement, you have 1, 2, 4, 5, 6, and 9. So the intersection of A complement and B complement would be the numbers that are common to the two sets. And that would be 2, 4, 5, and 6. Okay? Are you still with me? Okay. Let us have some problem solving. A group of 50 students went in a tour in Palawan province. Out of 50 students, 24 joined the trip to Coron, 18 went to Tubataharif, 20 visited El Nido, 12 made trip to Coron and Tubataharif, 15 saw Tubataharif and El Nido, 11 made a trip to Coron and El Nido, and 10 saw the 3 tourist spots. Question: how many students did not go to the 3 tourist spots? Interesting, right? So to answer this question, all you have to do is to make a Venn diagram. But before that, you have to list down the given. And the given are the following. You have 10 students went to the 3 tourist spots. 11 went to Coron and El Nido. 15 went to Tubataharif and El Nido. 12 went to Coron and Tubataharif. 20 went to El Nido alone. 18 went to Tubataharif, and 24 went to Coron. And let us not forget that the total population, or the total students who went to Palawan province in general are only 50 students. So how do we deal with this? First, you have to make 3 circles or 3 Venn diagrams, since in the problem it was mentioned that they have visited 3 tourist spots: Coron, El Nido, and Tubataharif. So you have 3 circles. Next, you have to find the intersection of the 3 circles. So on our first given, you have 10 students who went to the 3 tourist spots. So that is why on the middle part, the intersection of the 3 circles must be 10. So you must write number 10 on the intersection of the 3 circles. Next, 11 went to Coron and El Nido. Since you have already written 10 as the intersection of the 3 circles, then the missing number would be just 1 because the intersection of Coron and El Nido on the left side of the diagram must contain only 1. So that the total of the intersection of Coron and El Nido must be 11 only. Next, the same principle applies to students, 15 students who went to Bataharif and El Nido. Since, again, you have 10 students who went to the 3 tourist spots, then 15 minus 10 must be 5, and that would be written on the right side. On my view, that would be on the right side of the drawing. So 10 plus 5 would be 15, and that is the intersection of Tubataharif and El Nido. Next, Coron and Tubataharif. That is only 12. Again, you have 10 already, so 12 minus 10, you have 2. Intersection, no, on the upper part of the number 10. You have to write 2. 10 plus 2, you have 12. Next, 20 went to El Nido. So for this part, you have to count the circle or the numbers inside the circle containing or labeled as El Nido. So you have 10, 5, and 1. So 10 plus 5 is 15 plus 1 is 16. But in the problem, 20 of them went to El Nido. So meaning, that would be A minus B, or this would be the set difference. So that portion on the lower part of 1, 10, and 5, you have to write 4 because 20 minus 16 is 4. Next, 18 went to Tubataharif. Again, you have to add all of them. So you have 10 plus 2, 12. 12 plus 5 is 17. Since you have 18 all in all, so 18 minus 17 is 1. So it has to be written only on the part of the Tubataharif. The space, the bigger space for Tubataharif. And lastly, you have Coron. 24 of them went to Coron. So you have 10 plus 2, 12 plus 1, 13. 13. 24 minus 13 is 11. That is why 11 is located on that part. However, if you will add all the 3 circles or the numbers written inside the 3 circles, that only sum up to 36. And we knew that all 50 students went to Palawan province. So how do we deal with this? So total population minus the total number inside the 3 circles. So that would be 50 minus 36. 50 minus 34 equals 16. And that 16 number is to be written in the universal set because these are the students who did not go to the 3 tourist spots. So, going back to the question, how many of them did not go to the 3 tourist spots? So, it is found in the universal set, and that would be 16. Only 16 students went to the Palawan province, but not on the 3 tourist spots. Okay, I hope you have enjoyed and you have learned something from my video. This has been ACCabalda at your service. Goodbye, everyone!